Hey everybody, in this video we are going to be listing all asymptotes and holes for the function below. This is number 14 on a playlist of pre-calculus final exam review material. And knowing me, I will probably go overboard at the end and graph the entire thing for you if you are interested in that. So first thing is first, let's go ahead and get this factored. The denominator is the difference of two squares, so that should be pretty easy to factor. It's 2x plus 3. 2x minus 3. If you don't know how to factor that, you're probably not a pre-calc student, if I'm being honest. Probably not in algebra yet. So why are you watching this? On top, being that it's saying that there's a hole, implying there's a hole, my numerator probably has a factor that matches one of the bottom, the denominator's factors, and the top has two plus signs, so that means that 2x plus 3 is the likely winner. Now, first times first has to be 2x squared, so that would have to be x, because contrary to what some of you did in the most recent assessment, 2x times x is 2x squared, and 2x times 2x is not 2x squared, that is 4x squared. Last times last has to be 9, so this has to be 3. I'm going to put a plus sign there, because when this is plus, it means both signs are the same when you factor, and they both are whatever that sign is, so they are both plus. Now, if I cross this out, that removes my removable discontinuity, or my hole. And then the function left for me to graph is x plus 3 over 2x minus 3. As for the hole in question, we're going to get our x coordinate by setting the factor equal to 0 and solving for x. That's negative 3 over 2 if I do it with a fraction. If I do it with the decimal, that is negative 1.5. To get the corresponding y coordinate of the hole, you're going to take that x value and fill it in for x. So whether we do it as a decimal or a fraction really doesn't matter. Negative 1.5 plus 3 on top is 1.5. On bottom, 2 times negative 1.5 is negative 3 minus 3 is negative 6. Now, some of you might see right away that that's negative 1/4. If not, you can multiply on top and bottom by 2. That would give you 3 over, we'll pull the negative, 12, and that reduces to negative 1/4. Another way you could do it is you can move the decimal over for each one, so you get negative 15 over 60. That also is negative 1/4. So if I want my ordered pair with fractions, I have negative 1/4. And if I want my ordered pair with decimals, that's negative 0.25. And there we go. I'm going to erase some of this work to save space. I didn't want that really to happen. So right there. Next, that's my hole there. My vertical asymptote is going to come from the denominator right over here. So my vertical asymptote will be, set that equal to 0, add the 3, divide by 2, at x equals 3 over 2, again as a fraction, or x equals 1.5 as a decimal. And lastly, my end behavior, aka horizontal asymptote in most cases in this class, not always, but commonly. Your end behavior is leading term over leading term. We're looking at x over 2x. We're going to analyze that and make our decision. That reduces to 1/2. So again, y equals 1/2 as a fraction, or y equals 0.5 as a decimal. So I have everything that was asked of me. That is my ordered pair for the holes, my vertical asymptote as both a fraction and a decimal, and my end behavior / horizontal asymptote both as a fraction and a decimal. So that's everything that they asked us to find. If we were to take it a smidge further, x equals negative 3 would get us my x-intercept of negative 3 comma 0. So I set the top equal to 0 essentially at the end right there. And my plug in 0 for x to get my y-intercept, and that's going to be 3 over negative 3. So y equals negative 1 is giving me 0 comma negative 1 as my y-intercept. And I think, actually I've been writing my y-intercepts in purple, so let's stay consistent like that. All right. So if I were to graph it, which again, it doesn't ask us to, but you know, more is more. I'm a maximalist. So what's the biggest number I'm working with? 1, 2, 3. Let's go out 4, 2, 3, 4, 2, 3, 4, 1. Oh, come on, right. 1, 2, 3, 4. 1, 2, 3, 4 in each direction. Let's go and plot these things. Negative 1.5 negative 0.25, so somewhere in that area. X equals 1.5 is my vertical asymptote. My horizontal asymptote is at 1/2 or 0.25. My x-intercept is 1, 2, 3 over there. My y, oh no, I didn't do that in purple. That's why. This should be in green. My bad. Slipped my mind. There we go. And now I could already kind of see it all coming together. So my one branch is going to be here approaching my asymptotes. And the other branch has to be up here because the asymptote is to the first power, odd asymptotic behavior. One side is pointing up and the other side is pointing down. And I also don't have any x-intercept, so I can't have it down there. And that's my graph. As for the domain and range, like we mentioned in the last video, for anybody that's curious, negative infinity until negative 1.5 with parenthesis, then again parenthesis 1.5, negative 1.5 rather, until positive 1.5, parentheses, and then parenthesis 1.5 until infinity is my domain. And my range from the bottom to the top is from negative infinity until negative 0.25 with a parenthesis, negative 0.25 until 0.5 with the parenthesis, and then 0.5 with the parenthesis till positive infinity. That would be your range if you were curious. And hopefully you listened to all that. We only needed the holes, and it's a very, very important that if it's a multiple choice test and this study guide is asking you to know how to do asymptotes and holes, that you very specifically know how to do those things. Okay, I am just taking it one step further, giving you the full graph for a full, more robust understanding. I hope that was helpful. I hope you appreciate the time I've taken to do that for you. If so, go ahead and give a thumbs up. If not, go ahead and give a thumbs down. Even if you, like, honestly, random side note, every time I watch a YouTube video, if I already watched it, I feel like I'm like, if you ever read Hansel and Gretel, I leave like my trail of breadcrumbs by liking a video. So if I stumble upon a video again and I see I already liked it, I know I already watched it. And I do put a thumbs down if I'm like, never come back to this again. This was terrible. This way I know I've seen it already and I don't waste my time watching it a second time. Or if I know it's something I thumbsed up, I found it helpful, then, or I liked it, whatever, and I did want to refresh on the topic, I know, oh, I like this video on this topic, let me revisit it, you know? So I do like to mark what I watch with a thumbs up or a thumbs down all the time. I find it helpful for navigating the YouTube space whenever I'm searching for something. Just a tip from someone who's a longtime YouTube advocate. All right, that's it for now. Thumbs up, thumbs down, questions, comments, concerns, feedback, requests, go in the comments section. Check the description box or the thumbnails on the screen for access to more of this. That's it for now. Adios.